Good day, ladies and gents. So we're on our last section of Unit 10. We're going to be doing radian notes, things that you need to have on your desk. You definitely want to have your calculator, a pen or a pencil, and your Hot Topics page. So we're going to be looking at this section right here, which is talking about how to change from degrees to radians and radians to degrees. And I'll zoom in a little bit right here. Okay, and also we're going to be having a throwback to arc length and sector area. So that right there. So that is a percentage. So arc length is a percentage of the circumference. So that distance right there, which is angle over 360 d pi. And sector area is percentage of the area, where it's the angle over 360 times pi r squared. And definitely want to remember that diameter, if you have this picture, so if it's not written on your Hot Topics page, you definitely should write this down. So radius is from the center to the edge, and diameter is all the way across, so diameter is equal to 2r. We agree that pi, we're going to use 3.14. If you put pi into the calculator, so pi, which is right here, we have this big long decimal, but we are not going to use pi. No, no, no. We're not going to use the pi button. We're going to use 3.14 every time we use that, just so we can agree that we don't have to use that big long decimal, because not everyone has a big calculator like me. Some people have only a 4-function calculator, and they don't have a pi button. So we're just going to use 3.14. So 3.14 for pi. Area is pi r squared. Circumference is d pi. Okay, so things that you should definitely have out on your desk. All right, so let's get started. All right, so radians. Radians versus degrees. Now, what are radians? Okay, a radian is a unit of angle measured based on the arc length. So 1 radian is defined as the measure of an angle formed when the radius is equivalent to the length of the intercepted arc. Recall the circumference of a circle is 2 pi r squared. Therefore, degrees is so degrees times pi over 180. That's how you change it into radians, and vice versa. Radians, we would just flip this, and so radians going back with 180 over pi. So basically, what we're saying is this. Just to give you an idea of what I'm talking about. There's radians, degrees are just another way of saying units. So, for example, we know that 1 foot is the same thing as saying 12 inches. So 1 foot is the same thing as saying 12 inches. That's what we're talking about here. Just talking about the same thing, but just in different units. So for our example, we know that pi is another way of saying 180 degrees. That's what's going on right now. So pi is the same thing as 180 degrees. So that's what's going on. So just giving you an idea, we're just converting from one unit to the other. Excellent. So, for example, if we have 30 degrees, so we're going to take the 30. Okay, we want radians. So we want pi. We want to get rid of 180 degrees. So we want the radians. We want to get rid of the degrees. That's what's going on. So you would just multiply straight across because there's like a 1 underneath this. That'd be 30 pi over 180. And all you have to do now is simplify. What can you take out of 30 and 180? Well, I can divide top and bottom by 30. So if you divide top and bottom by 30, okay, you would get 1 over 6 pi. Okay, which is the same thing as saying pi over 6. So this is the better answer. Right there, pi over 6. Okay, because that's what it's going to usually look like. All right, so then over here, so 2 zeros. So we want pi, we want to get rid of the 180 degrees. So that'd be 220 pi over 180. And all we have to do is simplify. So 220 divided by 180, that is a decimal. So we want to see if we can simplify. Well, I know for a fact I can at least get it out of 10. Oh, and I can get it, so I can get off 2. So I can divide top and bottom by 20. So divide top and bottom by 20. I'm just simplifying. So 220 divided by 20, I get 11. 180 divided by 20, I get the number 9. So 11 over 9 pi. And that's my final answer. Okay, now what is a faster way? Okay, so if you have this kind of calculator, another way you can do this. So you see the fraction bar right here? So another way you could do this is go 30, push this button right here, 180 equals, and we get 1 over 6. So 1 over 6, and then we just have to attach the pi on there. And so the better answer is pi over 6. Now, but what about this one? Okay, now on this one, you do the same thing, 220 over, so the fraction bar, 180 equals. Now this is an improper, that's a mixed fraction. So what we're going to do is, you see right here, it goes from mixed to improper. So you're going to push the second button, and then push the fraction thing again, and then push equals. And now it's an improper form. So that's the one we want. If you give me the other way, this will be wrong. Nope. Okay, so that one, this part is wrong. You would have to do the improper way. Okay, cool. But we're not going to be dealing with that too much, except for just practice. What we really want is to change all of our radians to degrees, because we are comfortable with degrees. We are very comfortable with degrees. Okay, so let's do some practice problems. So 5 pi over 6. So 5 pi over 6. We want 180 degrees. We want degrees. We want to get rid of the pi. So you just need to multiply straight across. So 180 times 5, we get 900 pi over 6 times pi is 6 pi. The pi is crossed out. So 900 divided by 6, and we get 150 degrees. And that's it. That's your answer, 150. That's what we're going to be doing mostly right there. So these are just going to have a couple of practice problems going from degrees to radians, but what we really want are radians to degrees, because we are comfortable with degrees. Okay, let's do number 4. All right, same idea. All right, so we have 7 pi over 9. We're going to multiply by 180 over pi, because we want degrees. We want to get rid of radians. Multiply across. 7 times 180. We get 1260 pi over 9 pi. The pi is crossed out. 1260 divided by 9, we get 140, and that's your answer. Awesome. Okay, number 5. So number 5, so we have 4 pi over 3. We want degrees, so 180 degrees. We want to get rid of radians, so divide by pi. Multiply straight across. 4 times 180. We pop out with 720 pi over 3 times pi is 3 pi. The pi's cross out. 720 divided by 3, we get 240. And that's your answer. Okay, number 6. All right, so 5 pi over 36. We want the 180 degrees. We want to get rid of the pi radians. So multiply straight across. 5 times 180. We get 900 pi over 36 pi. The pi's cross out. 900 divided by 36. We get 25. All right, so you should pause and give 7 and 8 a try. See how you guys do. All right, go ahead and push play again, hopefully. All right, let's see how you guys did on 7 and 8. So 7 pi over 4. We want the 180 degrees. We want to get rid of the pi radians. Multiply straight across. 180 times 7. You get 1260 pi over 4 times pi is 4 pi. The pi's crossed out. 1260 divided by 4, you get 315. Hopefully you got that right. And number 8, we have pi over 2. We want the 180 degrees. We want to get rid of the pi radians. So multiply straight across, that's 180 pi over 2 pi. The pi's crossed out, and you're left with 90 degrees. And that's your final answer. All right, let's flip over into the back. Let's go to page 23. All right, so now that was a build up to this next part. So we dealt with this before. Okay, so sector area, that is equal to the percentage of the area. Percentage is the angle, so I put theta. That's what angle stands for. So a circle with a horizontal line through it that looks like a Pokemon ball is equal to the word theta, which means angle. So it's theta over 360, or you can just say angle, whichever one you prefer, times pi r squared. So percentage of the area. And then arc length. So arc length is equal to the percentage of the circumference. So that is theta over 360, so angle over 360, times d pi, or that's diameter times pi, or 3.14. Excellent. Okay, so that should just be a reminder. So let's do these problems. Okay, for these two problems, they specifically said that they want arc length and round to the nearest hundredth if necessary. All right. So see how this is darkened? So they want this right here. So this arc length right here. Now at the second, we have 3 pi over 2. So let's think this through. 3 pi, so 3 over 2 pi basically. So 3 over 2 pi, and we want that to be in degrees. So we want 180 degrees. We want to get rid of the pi radians. Multiply straight across. So 180 times 3, we get 540 pi over 2 pi. Okay, the pi's cross out. So 540 divided by 2, and we pop out with 270. So this angle right here is really 270. So you can just ignore that and say 270. All right, so now that we have that, now we're in familiar territory. So they want arc length. So arc length is equal to the percentage of the circumference. So that would be the angle, 270, over 360 times d pi. Now let's take a second here. We know that this right here is 16. Now is that the radius or the diameter? That is the radius. So if the radius is 16, what would have been the diameter? 16 times 2 would be 32. So that would be d pi. So that would be 32 pi. So you just need to multiply across. 270 times 32, we get 8640 pi over 360. Now you just have to put it in the calculator. So we have 8640 times 3.14 divided by 360. We pop out with 75.36. And they said around to the nearest hundredth. And 100 has 2 zeros, so we go 2 decimal places. We're already at 2 decimal places, 1, 2. So we are done. All right, excellent. Number 10. Okay, so radius is 9, so what would be the diameter? That would be 18. They said degrees is 7 pi over 4, but we always want to have it in degrees anyway, so what's that really? So 7 pi over 4 is equal to, we're going to multiply by 180 divided by pi. All right, 7 times 180, we get 1260 pi over 4 pi. Pi's cross out, and you pop out with 315. So that's degrees. So we have the radius is 9, the diameter is 18, our angle is 7 pi over 4, or in other words, 315 degrees. Okay, and we want the arc length. So arc length is equal to the percentage of the circumference. That is the angle over so angle over 360, so it's 315 over 360, times d pi. So d is 18 pi. All right, multiply straight across. So, or you can just put that all in the calculator. So 315. So 315 divided by 360, boop, times 18 times 3.14. And you pop out with 49.455. Now, they said to round to nearest hundredth. So at this moment, we have 49.455. They said the nearest hundredth. So how many zeros does 100 have? 2. So are we staying at 49.45, or are we going to 49.46? Because that's the next number. Well, 0, 1, 2, 3, 4 versus 5, 6, 7, 8, 9. So the number after this is a 5. So if I take the ball and I put it at 5 and I drop the ball, would it roll back or would it roll to the next number? It would roll to the next number. So our answer is 49.46. And that is your final answer. Awesome sauce. All right. Let's go to number 11. All right. So this time they want the area of the sector. And, they said around to nearest tenth this time. Ooh, the tricky little buggers. Okay. Well, first of all, I am noticing that I have 17 pi over 12. All right, so 17 pi over 12. So let's go ahead and change that to 2 degrees. So 17 pi over 12, we want the 180 degrees. We want to get rid of the pi radians. So 17 times 180, we get 3060 pi over 12 pi. So the pi's cross out, and 3060 divided by 12, we get 255. So that's 255 degrees. Excellent. Okay, now they want the area, so they want the sector area, right? They want the sector area, which is percentage of the area. Okay, so that would be the angle, which we got 255 over 360, times pi r squared. Now let's see. Radius is from the center to the edge. So the radius is 14, the diameter would have been 28. So pi 14 squared. All right, so we want to get rid of the, so a lot of us want to need to travel backwards, so we want to get rid of the square first kind of thing. So 14 squared, okay, that's really 196, by the way. Okay, so times 3.14 times 255 divided by 360. And we get 435.936666666667. Okay, and they said to round to nearest tenth if necessary. How many zeros does 10 have? 1. So the question is, are we staying at 435.9, or are we rolling to the next number? So you see how it's 59? The next number would be 60, or 435.6, so 60. So 59 would turn into 60. The better way to say that is 436. Right? Okay, so the question is, are we staying or are we going to the next number? So that decision is made by the number after it. So 0, 1, 2, 3, 4 versus 5, 6, 7, 8, 9. Okay, so we take the ball, we go to 3. If we drop the ball, does it roll back or does it roll to the next number? It rolls back, so we stay where we're at. So 435.9 is your answer. All right, number 12. Okay, so on number 12, okay, so we have the radius is 10, so the diameter would have to be 20. We have our angle is pi over 2. We want to change that to degrees. So if so we want 180 degrees, we want to get rid of pi radians, multiply straight across. The pi's crossed out, and you're left with 90 degrees. So this is really 90 degrees. Okay, and we want the sector area, which equals percentage of the area. Percentage would be the angle, 90 over 360, times pi radius squared, so pi 10 squared. All right, so basically type this in backwards in your calculator because we want to get rid of the square first. So 10 squared, which is 100, times 3.14 times 90 divided by 360. We pop out with 78.5. They said it rounds to nearest tenth. How many zeros does 10 have? 1. We're already at 1 decimal place, so we're done. So we're done with that particular problem. Okay, 2 more, and then we are done for the day. And then you get to do practice. A wire. Okay, so this one, we're just starting over. We don't know if this is sector area or if this is arc length. We don't know. We just have to read. A wire is running along the side of a circular building. This much of the building. How long is the wire? Okay, so if the wire is on the outside, so are we talking about sector area or are we talking about arc length? Well, it's on the outside, so that's a percentage of the circumference because it's on the outside. So we're looking for arc length. So arc length equals percentage of the circumference, right? So, well, we have 3 pi over 2, so we have to fix that first. So 3 pi over 2, we want 180 degrees. We want to get rid of pi, radians. So 3 times 180, we get 540 pi over 2 pi. The pi's cross out, and you get 270 degrees. That's a bubble thought. In addition to that, they said, how long is the wire running if you have your radius is 5, so then our diameter would have to be 10. All right, so these are the things that we need to do this. So percentage would be the angle, 270, over 360. And circumference is d pi, so that would be 10 pi. All right, just type it in the calculator, right? So 270 divided by 360. Okay, boom. And then multiply by 10, multiply by 3.14. We pop out with 23.55. And they said to round to near hundreds, which were already there. So there's our answer, 23.55. Excellent. And number 14. Okay, a water sprinkler sprays water over the distance of 30 feet. Okay, so we have a sprinkler system right there in the middle, and it sprays in every direction, right? So it sprays 30 feet. So that right there is the radius. Radius is 30, so then the diameter would have to be 60. And they said it's rotating through an angle of pi over 18. So that means that if we have pi over 18, and we need to change it to degrees. So multiply by 180, divide by pi, multiply straight across, 180 pi over 18 pi. The pi's crossed out, and you're left with 10 degrees. How much area does the water cover? So we want the sector area on this one. So that would be percentage of the area. That is the angle, which is 10, over 360. Okay, pi, radius. Radius is 30 squared. Okay, put that in the calculator, right? So basically, because we have the square there, let's go ahead and type this in backwards. So 30 squared, we get 900 times 3.14 times 10 divided by 360. We pop out with 78.5. So we get 78.5. And that's it. And it's already rounded to nearest, so it said nearest hundredth, but we don't have two decimal places, so we just stay where we're at. That's everything you guys need. Hopefully you guys understand anything. Let me know if you have any questions. Other than that, have a great and awesome day.